All right, guys, so we're going to talk a little bit about the spread of data. We've talked about the mean and the median, and we've compared those. We did talk about the range as well. I'm going to give you a little bit more insight into these box plots and just exactly what kind of information we can get from them. We talked a little bit about how to create one, and if you've forgotten that, you can look back at the last video. But what we know from these box plots is that, of course, we have a minimum piece of data, a maximum piece of data, and then we said this is our median, and then we have the lower quartile and the upper quartile, or Q1 and Q3, right here. And what that represented was the median of the lower half of the data and the median of the upper half of the data. Well, what I didn't talk about last time was the fact that we know when we have a box and whisker plot, or a box plot, that 25% of the data lies in each of these sections. This one's kind of small, so I have to put my 25% here. So if somebody were to ask you how much of the data for this particular data set is below 60, you could say that 25, 25, 25, total of 75% of the data is below 60. And we'll talk more about that later. But today we're going to talk more about something called interquartile range. It's a big word. Hope I spelled it right. But it's really pretty simple to get. We're going to compare it a little bit with MAD, mean absolute deviation, which we talked about earlier, because they kind of give us the same information that we want from the data. Interquartile range is very easy to get. It's just Q3 minus Q1. In other words, for this data right here, our Q3 is 60, our Q1 is 20, 60 minus 20 is 40. So our IQR, or interquartile range, is 40. For this data here, we have 70 minus 10. So our interquartile range for this data is 60. For this data here is 70 minus 20, or 50. Here we have 70 minus 30. So our interquartile range is 40. And our last example, our interquartile range is 50 minus 30, so it will be 20. Now, what does this mean? Well, what this guy is analyzing are his miles driven each month. And he might want to know what his average, or the median of his mileage is, so he could tell that from the graphs here. But actually, it looks like it's about the same each time, 40, 40, 40, 40. So another piece of data that might be more helpful to him is how much did his driving vary each month? Vary. That's how much did it vary? That's a vocabulary word I hope that most of you know. Variability of data. So if we look at this, we can see that, let's see, in September, it looks like he had the greatest variability with 60. His interquartile range was 60. In December, he had the least variability. His interquartile range was 20. So that's the kind of thing you might use interquartile range for. Now, looking at these dot plots, we're going to talk a little bit more about MAD, or mean absolute deviation. And I'm not going to go through how to calculate it because we did that in an earlier video. But if you remember, you take the mean of the data, you have to add it all up and divide it by the number of data pieces that you have, and then for each data piece you calculate how far it is away from that mean, and then you average all those together, and that gives you mean absolute deviation. I'm not going to go through and calculate it for each one of these, but I do know that for this one down here, our MAD would be 0 if we were to calculate that out. Our MAD here would be 2.22. This is uniform distribution. We'll talk about that in just a minute. MAD here is going to be 2.68. Here it's going to be 1.12. And here our MAD would be 1.56. So again, we can look at this data and we can tell that our mean absolute deviation down here is 0. Now, why is that? Well, this is our median. It's also our mean. Well, there are no other data pieces. So there is no deviation. So that's why it's 0 here. We have the most deviation here at 2.68. We have our mean or median will be around here, and then we have a lot of data points that are far away from that middle point. So that's why it's so big. And then the other ones kind of fall in between. Okay, hopefully that's enough for now to get you through today's lesson, and we'll talk more about this interquartile range and mean absolute deviation later.